Hello, hello, hello. Good, whatever it is where you are. It's good evening here. Might be good afternoon, good morning. Hello, everyone. We'll make a start. Well, it is my timer says zero there, so we'll make a start now. Let's get rid of the timer. Move on. Welcome, everyone, to this Python for Beginners workshop. Some of you may have been here for last week's workshop or the one the week before. Today's project is yet different. So if you've been to those workshops, this is a different project. If this is the first time you're turning up for these workshops, it's perfectly fine. They don't carry on more from each other. They're all beginners workshops. There are different audiences here. Some of you are on Zoom. If you're on Zoom, you know who you are. You know how Zoom works. At any point, feel free to raise your hand, and you're more than welcome to ask questions using your voice, or of course, there's the chat as well. Others are watching this streamed on some platform, whether it's YouTube, X, LinkedIn, Facebook, whatever. In most of those platforms, you can also ask questions. I think X doesn't allow you to ask questions, at least they don't come to us. For all the other platforms, wherever you ask a question, I have my second screen there. So wherever you look, wherever you see me look that way, I've got a couple of chats. So whatever questions come from you, I should be able to see them. Quick intro. My name is Stephen Gruppetta. I'm one of the core team members here at Real Python. And I'll be with you for the next 60 to 90 minutes, maybe longer, depending on how many questions you have. We're going to be working on a project, but your questions can lead us into different parts. Just to make sure everyone is in the right place, this is a workshop for beginners. So if you're brand new to programming, you've never done programming before, you've never done Python before, this is the right place for you. If you've done a bit of Python, so that's also fine, of course. Some of the topics I'll be covering today, you will have seen them before. But one thing I like to do a lot is not just to discuss how to do things, but why we do things the way we do. So even if you're not brand new and some of the topics we'll talk about today you're familiar with, I'm sure you'll get to understand them at a deeper level. And that's what the questions are for. Often the questions are what lead us to properly understanding things. So don't be shy, ask questions at any point. There will be a Q&A at the end, but, and this is a really important but, I'd rather you ask questions whenever they come up. So don't wait till the end. Ask questions at any point. As I mentioned before, those of you on Zoom, feel free to raise your hand if you'd like to give my voice a break and use your voice. If not, there's the chat in Zoom or the chat on YouTube, Facebook, LinkedIn, whatever. This is a project we're going to be working on today. It's a hands-on project. It's best if you can code along with me. It's fine if you can't, but if you can code along with me, I will go at a reasonable pace so that you can keep up with me. Sometimes these sessions can go too fast. I will not do that. And if I do, let me know in the chat. I'll go slow enough to make sure you can all keep up with me. We'll start from the basics. So we'll start a bit slow and then we'll pick up pace as we go along. But I'll always make sure you have time to code along with me. So if you can, that's the best way to get the most out of this workshop. We've got 60 minutes, 90 minutes, depending on how long it takes. So it's still going to be a relatively self-contained project. It's a self-contained project, but of course, we're going to be covering many topics. We're not going to go into excessive detail on each one of those topics. Otherwise, we're here for 10 hours rather than one. However, I've got a set of resources for you. So you have the link there, realpython.com/bonus. Every topic we're going to be discussing today, I've got resources where you can take the next step at any stage you want. So if you want to read further or watch video courses on Real Python, I will keep reminding you. So, and I'll have a note of this. So you don't need to write it down now, but before the end of the session, this is where you can go to get the resource kit linked to this workshop. Good. I've covered everything I think I have to say. Let us make a start. I've mentioned this before, but I'll mention it again. The session we'll spend about 60 to 90 minutes working on the project. I will leave enough time for a Q&A at the end, but do not wait until the end. At any point, feel free to ask questions. You won't be disrupting my flow. I'm very happy to answer questions as and when they come. Okay, let me shift to my coding editor. I'm using PyCharm, but it doesn't really matter what you're using. As long as you have something where you can code in Python, that is all you need. So we're going to be working on a project, as I've said, and we need a context for the project, right? So here it is. Um, let's assume we've come up with a new lottery system. And I'll tell you how it works in a bit. What we'd like to do here is work out the odds of this lottery. So you've come up with a system and you think, well, how many people will end up winning in this lottery? The lottery is as follows. People get two random numbers between 1 and 20. And if one number is exactly the double of the other number, you win. Otherwise, you lose. So this is a made up example, right? I don't think there's a lottery like this that exists. But the point here is to work on a project that's going to help us learn quite a few key topics in Python. A reminder, that's our aim. Our aim is to learn Python here. Now, this lottery, you get two random numbers between 1 and 20. If one happens to be the double of the other, you win. Otherwise, you lose. Those of you who are comfortable with the math, you can actually work this out. It's not terribly difficult to work out the probability of winning, the odds of winning mathematically. But we're not going to do that. We're going to write a Python program to do it for us. And the way we're going to do it is we're going to first write a program to simulate this lottery, to create two random numbers and then tell us you've won or you've lost, depending on whether one number is twice the other. Once we've done that, we'll then repeat that a large number of times, 1,000,000 times, 10 million times, so that we can figure out of those million times or 10 million times, however many times we choose to run it, how many times did the player win, how many times did the player lose, and that will give us the odds. This is again, the aim here is to learn Python, but this is a common use case of Python. Prior to in my first career, in my first life, I was a scientist, and I did a lot of my work was actually creating programs to simulate real world things. They were more complex than the topic we're doing today, right? But the idea is the same. So it's a nice real world example, even though this particular lottery example is not one that exists in real world. Okay. Let me make sure that all my screens are set up. Well, my second screen is all fully set up. Again, a reminder, I'll be looking at the chats. I've got several chats there, depending on where you are. So at any point, I'll keep glancing there. When I see questions, I'll either answer them straight away or at the appropriate time. So please do ask. Okay. So we need to start to create one run of this lottery. So we need two numbers between 1 and 20, and that's the first thing we need to do. I am going to start from the basics, right? So I'm not going to assume any knowledge. So let me start by coming up with numbers myself, right? And in programming, one of the most important things is when we have any information, it could be a number, it could be a name, it could be something more complex, we need to be able to store it somewhere in our program. Why? Because I want to use it later on. And this idea of storing information in a program is one of the most essential tools in programming. And let me start by creating a label. Now, this could be anything, right? You can call this whatever you want. There are a few rules on how we can name things. You may have noticed I did not put a space there. We can't put spaces when we name things. That's why there's the underscore instead. If you don't like the underscore, you can remove it, right? But often we put an underscore there. Now, you can see it underlined in squiggly red. If I try to run this code, Python is going to complain. It's going to say, once it appears on the screen, on line 1, which is the only line we have, name first number is not defined. It looked up this name and it said, I don't know what this is. But that's okay because we are going to create this label. That's what the equals does. And for the time being, I'm going to pick a random number myself. 7. We'll make this properly random later, right? But for now, I'm going to pick a number. So let me do the same thing for, let's call it second number. Again, you can call this anything you want, anything before the equals. It's up to you what you want to call it. But normally, let me pick a random number. Let's go with 17. You want to make this name descriptive. So it describes what the value that the data is. Okay, I will speed up soon, but let's stop on this because this is so central to all of coding. In each of these lines, I like to think of this as two things are happening here. We are storing information. So let's imagine there's a box. That's where we store stuff, right, after all. And each one of these lines brings in a box. That's what the equals does. It's storing information. First, I'm going to look on the right-hand side. This is the information, the data I want to store. In this case, is the number 7, the integer whole number 7. I'm going to put it inside the box. But then I want to label the box. So on the outside of the box, I'm going to stick a label. And that's what I put before the equals. This is the label you choose. Why? Because now I have a box. The label tells me which one it is. And then I have a second box, labeled second number. Inside it is a different number. And these are what we call variables in programming. But for the time being, you can think of them as labels outside of box, telling us where to find that information. So whenever I type in now, for example, first number, I'll tell you what print does in a bit, although many of you will have seen it. Print displays whatever information goes inside the parentheses on the screen. And you can see that it doesn't show me FIRST underscore NUMBER. It shows me the contents of the box, which in this case is the number 7. So far, so good. Good. Print is one of the most common, one of the most boring, but also one of the most used tools in programming. It's what we call a function. The best way of thinking of functions in programming, it's like they're the verbs of the language. They do something. And one way of recognizing functions is they always have parentheses after them, the round brackets. Sometimes there's something in the parentheses, such as in this case, I'm asking Python, this is the information I want you to print out on the screen. You'll see that there are functions that might have more information, some that have nothing, but they always have a parentheses following the name. We'll see more functions as we go along. Good. Let's move on. Now, instead of printing just first number here, let me print something else. Let us show what the numbers are. Your first, your numbers, let's say, are. Now, if you're coding along with me, what I'm going to write next, I will change in a bit, just so that you're aware. And for the time being, I'm going to say your numbers are 7 and 17. And if I run this, it's going to tell me your numbers are 7 and 17. First of all, you may have noticed that this time, inside the parentheses, I put something in quotation marks. It doesn't matter, by the way, in Python, whether I use single or double quotation marks. This makes this a different type of information. Whereas these were whole numbers or integers, this is what we call a string of characters, or a string for short. This means anything inside the quotation marks, they're not Python words. They're not words Python is meant to understand. They're characters for human beings to understand. So we have two different types of data here, integers and strings. And we'll see more as we go along. A quick reminder, I mentioned this at the beginning, but I'll mention it now for people who are jumping in and out. These are variables, and this is the data we put inside variables. This may seem simple, but there's a lot to it. And at realpython.com/bonus, I've collated a list of resources. Two of them rather, talk about variables and how variables interact with the things we store inside them. Likewise, print may seem very simple, but input-output using print, and there's a cousin of it, input, which we won't use today. Once again, at realpython.com/bonus, some of the resources tell you more about how we input and output. Because what print is doing is it's communicating between the program and whoever is using the program. The bottom of my screen is what the user sees. The top of my screen is what the programmer sees. Of course, here we're seeing them all in one go, right? Okay, there's a problem with this. The problem here is that the 7 here and the 17, let's start with 7. This is not the same as the 7 there. You can notice here that even the color is different. Yours might have different color schemes, right? But it's possible that this number 7 has a different color to that number 7, even on whatever you're coding on. Why? Because Python understands this as the number 7, the one that comes after 6 before 8. This, however, is different. This is the character, the symbol for the number 7. In programming, these are two distinct things. That's the actual number. I can add 1 to it and it becomes 8. This is simply the symbol we use for 7. Why does this matter? This matters because here I've just put in a couple of numbers. But in reality, soon we're going to ask the computer to pick random numbers for us. So I can't type in the numbers I need here. I want the computer to figure out what first number and second number are. So let's try something else. Can I do the following? After all, I told you a few seconds ago that first number and second number are the labels of boxes, and the information is inside them. Let's see what happens if I run this. I'll have a problem. I also told you that anything inside quotation marks, Python considers as just a string of characters. So first number here, Python sees this as FIRST underscore. There again, just the characters. It doesn't understand it as the label I've created in my program. So I need to go a bit further. I need to tell Python, like, I want you to work a bit harder here. So I've mentioned that this is a string of characters. The quotation marks tells you that. Python has a fancier type of string, one which will allow us to do a bit more than just show characters. And the way we can achieve this fancy string is by putting an F right in front of the open quotation marks. Now, the F doesn't stand for fancy. It would be nice if it did. It stands for formatted string, because we are going to format the string in a more versatile way. So what I'm going to do is, I'm going to take first number and enclose it in curly brackets or braces, or call them whatever you want. The type of brackets and parentheses we use is really important in Python. You can't just pick the one you like, as you can probably imagine. I mentioned that after print, which was the function, we always have the parentheses or round brackets. Depending which part of the world you are, you'll call these different ways. In this case, we need the curly brackets or braces. Let me run the code for now. I've only done it for first number, right? Not for second number. Notice that first number is now black on my screen. The colors may be different for you, but probably you'll see that Python now understands this as the label first number. It's not a string that my screen shows as green. And here you can see that your numbers are 7. And of course, we know that we need to do the same thing with second number. So that's what the F string does. It allows you to still create a string, but with the flexibility that Python will fill in the blanks. Wherever there's a curly brackets or braces, it's like a placeholder, and Python will say, let me check what first number is. It's number 7. So it replaces it with 7. And if I run it again now that I've done the change, 7 and 17. So one more thing we've added here, F strings. These are relatively new in Python. They've been there for many years now, but in Python's life cycle, they're rather newish. If you want to find out more about F strings, once again, realpython.com/bonus. A couple of the resources there focus on F strings and dive quite a bit deeper onto this topic. So I'm mentioning lots of topics today, but there's plenty more to dive in all of these. Okay, this means now that if I change this number, so if I go to 2 here, your numbers are 2 and 7. Why? Because first number will always refer to whatever is in this variable, or in this box, if you like. Let me have a look. So far, so good. Okay, let's start making this random now, because at the end of the day, I don't want to have to come up with a number myself. The whole point of writing this program is because I'm going to ask the program to run this lottery a million times or 10 million times. So I don't want to type in the numbers myself. I want these to be random numbers. Now, Python is a programming language. So it has lots of tools that come within it. We've seen a couple here, things like print, things like equals, which is used to store information, storing a number in this case, with the label second number or whatever it might be. And there are many others. We'll see many more of these tools that are always there. All you have to do is write print and it's there. All you have to do is type equals and it's there. But Python is a really broad language. There are commands for everything you can imagine. If you're working in science, as I did in the past, there are lots of commands specifically for science, others for finance, others for web development, others for data analysis. Anything you ever want to do, Python has commands for those, but they're not all there easily available. Sometimes you need to bring them into your program first. And that's what we're going to do in this case. And the way to bring extra commands into your program is using the Python keyword, as we call it, import. And in this case, I'm going to import something called random. So we call this a module, but let's visualize it. Think of it as a folder with lots of commands inside. And we went to the library and brought it onto our desk. My desk is my program, right? So now I've got this folder labeled random on my desk. So whenever I need to use it, whenever the program needs to use it, it's there, ready to be used. So you can probably guess what sort of commands the random module, this random folder, has inside. Stuff to do with randomness, to create random numbers, to create random shuffling, etc., etc. So let's start by replacing these numbers. I don't want first number to be 2 anymore. Now I want it to be, a reminder for those who perhaps joined a bit later, we're simulating a lottery that has 2 random numbers. And if one number is the double of the other, that's how we win. So I want Python to generate random numbers for me. Now, the command I need is in the folder labeled random, or the module labeled random. So I need to ask Python to pick it up from the desk, if you like. Random, that's the folder. Open it, and the dot does exactly that. We'll see the dot we'll see it often in Python. And here you can see that I can look at all the stuff that's inside the random folder. And in this case, I want to use one called randint. No prizes for guessing what rand stands for. Random and int, I've mentioned integer before, whole number. So randint is another of these functions, like print, the verbs of the language, that will do something for us. It will create a random number. But I mentioned that functions need parentheses after them. Remember print? So randint is also a function. The difference is that I need to fetch it from random. That's why it has random dot. But randint is a function like print. In this case, randint needs 2 bits of information. It's going to pick a random number. I need to tell it between what and what number. And in my lottery, it's between 1 and 20. So on line 3, Python will look at random and say, yeah, we've brought it into the program. Let me open the random module, find randint, use 1 and 20, and it will give me back a random number, a number between 1 and 20. And as you can imagine, we're going to do exactly the same thing for second number. I'll change these lines a bit later on, but for now, this will work. Let's run the code now. And my code now says your numbers are 15 and 4. But yours will almost certainly say something else. Well, there is a small chance that you get 15 and 4, but in general, these are random numbers. And that if I run the program again, I'm going to get different numbers. Because every time I run the program, Python is picking a random number and storing it in first number, and then another random number and storing it in second number. So I've been able to pick 2 random numbers between 1 and 20 and display them. Derek has a question for me. Is 20 included? Now, I will talk about this a bit more later on. Yes, 20 is included. Let me confirm this to you. There's a but coming, right? But yes, 20 is included. Now, let me open up This is called an interactive environment. Um, Depending on what platform you're using, you'll find it in different places. You know you're there because normally you have these three chevrons, these three arrows. Don't worry too much if you can't find it in your computer. I'll just demonstrate things on it. Let me, it's a different environment, so I have to import the random module again. And let me try random.rendint. Let's go for 1,3, which is a smaller range. And I'm going to run it a few times. There you go. 3 has come up there. And you can see 1, 2, and 3 are all coming up. So rendint includes both beginning and end. But this is very rare in Python. In fact, rendint is a bit of an anomaly. We will see later on that almost always in Python, when you have a range of numbers, the first one is included, but the last one is not included. I'll come back to this later on, but I just want to, since someone asked me, 20 is included in rendint, but this is a bit of an unusual behavior for rendint. Most other things in Python would not include the endpoint. Marco asked me on Zoom, how do you know which functions are included in certain libraries? That is one of the hardest things in Python because Python is so huge. There's a number of ways. The best way, so random is one of the modules that's part of the Python package. So when you install Python, random is a module that's there. That's why if you have Python on your computer, import random works. So if you go to the Python documentation, it's docs.python.org, there will be information about everything, including the random module. So if you had to go to Python, docs.python.org, look for random, you'll find a page which will tell you, here's what the random module has. And you'll be able to look through every single thing in there. If you just want to peek inside without too much information, if you do random dot, shown in front of me, and whatever editor you're using, almost certainly you'll have this autocomplete. There, I can see all the things inside random. You can ignore these weird ones at the end and anything with underscores, but otherwise, that's all the things you can find in random. Now, some of these may make sense to you, some of them may not, depending on, some are shuffle, for example, we're going to use it later on, may be obvious. Others, you may need to be familiar with the sort of the subject knowledge in terms of probability distributions in this case. But this is how you find, if you just want to have a look at what's inside, that's the easiest way. The documentation is the other way to look at it. A third way is to look at comprehensive articles like stuff we have at Real Python. All of these basic modules, we will have lots of articles exploring them in detail. So, and with practice, the more you use these modules, the more you're familiar with what they are. One thing you should never do is say, here's a module, I'm going to learn it all from beginning to end. Because if you do that, you're never going to get anywhere. There's so much stuff in Python. It's good to have an idea of what's inside, but then it's also good to get to the point where you need something, you sort of know, for example, you need something which deals with randomness, and you think, there's the random module. Let me go and look for what I need in there. Otherwise, if you try to go through every single thing in random and then every single thing in every other module, you will not get there. There's a lot of stuff in Python. Okay, so we've covered those questions. Let me speed up. I did tell you I'm going to start slowly, but now I'm going to speed up a bit. Next, now I have two random numbers, I'm printing them out. Next, I want to figure out whether one of them is the double of the other. Now, we need to be careful here because I've run this code, right? And in this case, I've got 20 and 14. The first one is larger than the second one, but that may not always be the case. This is the case here. There we go. In this case, the second one is larger than the first one. So we always need to think of what the requirements of our problem are. Here we need any of the numbers. We want to check whether it's double the other number. So we have to be a bit cautious. There are many ways of doing this, right? But in order to explore more tools, hi, I can see some people there on LinkedIn saying hi, hello. By the way, those who join late, I am recording this session And at realpython.com/bonus, in addition to the resource kit, later today or tomorrow, once the recording is ready, we'll send an email with the link to the recording. So that's something else you'll find in the resource kit. So if people come in late or need to leave, you will have the full recording later on. There are many ways of figuring out this problem, right? I can't simply say if the second number is twice the first number, because I don't know that the second number is the larger one. We could, play around with this in many ways, but I'm going to use a few more functions like print. And one of them, I'm going to use print again, but inside print, I'm going to use another function called max. You can probably guess what max does. And I'm going to put 2 bits of information in max. First number and second number. By the way, did you notice that my editor is auto-completing things for me? Yours is probably doing that as well. Do use autocomplete. It makes life easier. Just hit enter when you see the thing you want at the top. So I'm printing 2 things now. The same thing I was printing before, this formatted string, this F string, but then I'm just printing whatever max first number comma second number gives me. Notice I have 2 functions here, one inside the other. I'm highlighting the max function. Max, open parentheses, something, comma something, close parentheses. But all of that is within print, which has its own parentheses. Let me run this. Your numbers are 14 and 19, and the maximum of those 2 is 19. So we get an idea. We can always find a larger one using max, and drum roll, what's the other one going to be? Of course, it's going to be min. So if I do min, your numbers are 15, 13, and 13 is the minimum. So I have an easy way of telling Python which is the larger one, which is the smaller one of these 2. So now I can check, is the larger one exactly equal to twice the smaller one by using max and min. I'm going to delete this line, but don't worry, I'm going to write it again soon. Now, new topic. I did say we're going to cover many topics. We've asked Python to pick 2 random numbers for us, and we're printing them out after fetching the random module. Now we need our program to make a decision for us. Is the larger number exactly equal to twice the smaller number? We know how to get larger and smaller with max and min, but I need Python to figure out whether one is exactly equal to twice the other. And this is not a decision I can make as the programmer, because I don't know what the random numbers will be. I need the program to make this decision for me. And programs making decisions is one of the most common things that programs do. And in Python, we do this very similar to how we do it in English, starting with if. So we're going to say, let me say this in English first. If the larger number is exactly equal to twice the smaller number, tell me you've won. If not, otherwise, tell me you've lost. That's what I want to write in English. In Python, it's going to be a bit different, but let me write it down. So I want to say if the larger number, and we've seen that larger number is max, first number, comma, second number. So that is going to give me whichever the larger number is. If the larger number is equal to twice, 2 times, the smaller number, which is min, first number, second number. By the way, this is not the only way of doing it, right? There are other ways, even more efficient ways. But the aim here is to learn stuff. So I'm not trying to find the most efficient way here. I'm simply getting us to think about what's happening. Good. So I've put in some other syntax there that I haven't talked about. The colon, which we will see a lot in Python and today. But before coming to the colon, some of you might be thinking, oh, hey, Stephen, you've got a typo. You've put in 2 equals by mistake there. No, I will make mistakes at some point, trust me, but this is not one of them. The double equals is not a typo. So why do we need double equals there when 1 equals was enough there? After all, in English, we say first number equals random not indent, and larger number is equal. In English, we use the same word, right? Or in other languages as well, probably. But in Python, these have distinct meanings. Let me go back to lines 3 and 4, which I talked about. This is what we call an assignment. I talked about it as storing information in a box. So a single equals says, bring a box because I want to store something in it. Whatever is on the right-hand side is the object I want to store, the item I want to store. And whatever is on the left-hand side is the label. And once I've done this, I've got some information stored in my program. That's a single equals. The highlighted section is doing something very different. It's not assigning anything. It's not creating a box and storing things. It's asking Python, can you look at whatever is on the left of the double equals and whatever is on the right of the double equals? There are two things there. Can you check whether they're equal? If they're exactly equal, give me a thumbs up, which in Python is the word true. If they're not equal, give me a thumbs down, which is false. That's why we need double equals, because we're asking a different question here. Are these two things, what's on the left and what's on the right, are they equal? And notice that I'm doing 2 times. That's multiplication as it is in most computing things. The colon is a punctuation mark we'll see a lot of in Python, and it's showing us that a chunk of code is coming up which belongs together. In this case, if the word if, so if the word if is followed by something that Python sees as true, and remember, equals equals will give us either a true or a false, then if it is true, whatever lines of code come after the colon, Python will do those lines of code. For example, print, yay, you won. And I can have more lines, right? Come again to play next time or whatever. Now, you may have noticed that when I hit enter after the colon, the cursor did not go to the beginning of the line. Instead, it started with a tab or an indent. And lines 9 and 10 both have this gap in the beginning, this indent. After the colon, we will always need to show Python which lines belong together. And that's what that gap is saying. So after the colon, all the lines that have the same indent, in this case lines 9 and 10, they belong together. They will happen only if that is true. However, anything I write afterwards, notice that line 12 does not have an indent. The blank lines don't matter at all, right? So blank lines are there just to make it look pretty. They have no meaning whatsoever. But line 12, the reason Python knows it doesn't belong to the if block, as we say, is because it doesn't have that indent in the beginning. So Python is using that space to determine which lines belong together. In this case, it's lines 9 and 10. A reminder, the blank line doesn't matter. We could remove it if you want to. Let's try running this and see what happens. Your numbers are 2 and 19. The end. 2 and 19 do not give us a win because 19 is not the double of 2. Therefore, lines 9 and 10, you can see, have been completely ignored. If I keep running it, at some point, I may be lucky. I'll run it a few times, but if it doesn't work a few times, there you go. I was lucky the 5th time I ran it. You can see that here your numbers are 4 and 8. But now, because 8 is twice 4, I say, yay, you won. Come again to play next time. And then the end. So now lines 9 and 10 actually did run because the if gave us a thumbs up. The larger number is exactly equal to twice the smaller number. So far, so good. I'll glance there to see if any questions come in, or incidentally, those of you on Zoom, I mentioned this before, right? If you're on Zoom and you want to raise your hand and ask a question using your voice, you're very welcome. You need to raise your hand first so that I can give you the mic, as they say. Okay. We have, let's do something else here. What if I want to display something? What if I want to, if this is true, I want to say, yay, you won, come and play in. If it's not true, I want to do something else. And there I can follow the if with an else. Let me write this down and then we'll look at the syntax. Sorry, better luck next time. So notice that the else matches the if because they go together. Now, else, unlike if, which needed something here, which Python understands as true or false, else doesn't need anything. Why? Because if this is false, then this is always going to happen. But notice that we still have the colon. And we're going to get a hang of what the colon does. The colon always means coming next is a chunk of code that belongs together. There needs to be at least one line there. Otherwise, what's the point of this? But you can have more lines. In this case, it's only line 12 on my code, which has this indent. Therefore, the code will do either lines 9 or 10 or line 12, but never both of them. Let me run it again and see what happens. Your numbers are 16 and 14, and you can see that now it said, sorry, better luck next time. So line 12 was executed this time. Good. So far, so good. Let me check. No questions come in? Brilliant. The if and the else are what we call conditional statements. So fancy word. You're asking Python to make a decision for you. The resources I have at realpython.com/bonus include more information about if, else. With all of these topics, there's a lot more to say. I'm not going to try to say everything about all of them, but that's why I've compiled a list of resources for you at realpython.com/bonus. Before the end of the session, make sure you get that so that you can carry on with your journey after this session. Good. Now, we're getting there. But before I move on, so far we're running this game once, right? So every time I run my code, it runs, it's like one ticket. 2-9, sorry, better luck next time. What I'm going to want to do in a few minutes is to run this 1,000,000 times and to keep track of how many times the player wins, and that will give me the odds. If I run 1,000,000 times, how many times I win, that will give me the odds. But before doing that, I want to remember we're exploring stuff in Python, right? So let's meander a bit. This depends on how we want to define our lottery, right? But there is a potential problem here. It could be that the same number comes up twice. So there's nothing saying that if first number is 5, second number cannot be 5. Let's try to deal with this. And again, there are many ways of dealing with this problem. One thing you'll learn as you code more in Python is that for every problem, there's always more than one solution. And as you become more proficient, you start to change the solutions you use and make them more efficient. But today I'm not worrying about that. Today I just want to explore things. So let's get rid of these lines for the time being. Now, I'm not going to delete these lines. Why? Because I might want them later on, or I might want you to still be able to see them. So instead, I'm going to add the hash symbol in front of each one of them. The hash symbol in Python says, hey, Python, ignore this line. Ignore whatever comes after the hash symbol. In this case, this is useful because we can simply temporarily remove these lines. The other place where we use the hash symbol is to write comments. Plain English comments, not for Python, but for other human beings. Incidentally, you may have noticed I used the shortcut there. We like to be lazy in programming, right? So never go and add hash symbols in front of every line if you have more than one line. If you select the lines you want, this is true for every editor you're using almost. And if you're in Windows, Control question mark. If you're in a Mac, it's Command question mark. And you can see I can toggle between them. So that's a nice way of taking a chunk of code and temporarily removing it or commenting it, as we say. So it's Control question mark on Windows, Command question mark on a Mac. Now, you can see that when I do this, I've removed those lines there. So Python is now complaining, lots of red there. It's like teachers at school, right? Underlined in red. Let me run this code and see what the error message is. And it says on line 6, name first number is not defined. Why? Because now on line 6, Python is looking for a box labeled first number, and there isn't one because I've removed it from there. That's okay. What I want to do is I want to create numbers in a different way to make sure that the same number doesn't come up twice. And what I want to do is I want to create a list of numbers 1, 2, 3, 4, 5, 6, 7 up to 20. And then take a couple of numbers from there. And if I take a number and another number, I can't take the same number twice. That's what I'm going to ensure. Now, um, we can use another of these built-in tools that Python has. And this one is called range. Parentheses. And the way range works is I give it a start and an end point. This is the but I mentioned earlier, so I'll come to y21 in a second. And this creates, as the name says, a range of numbers from 1. Now, I mentioned that rendint was a bit of an exception in Python. In fact, if it was redone today, probably they would change it because everything else in Python, whenever you have a range of numbers, the start is always included, but the end is almost always excluded. So range 121 gives me the numbers 1, 2, 3, 4, 5, 6 up to 20, not 21. This is something, it's a bit confusing at first, but you will get used to it. And this is most common in lots of places. Pause. Let me go back to my interactive environment. This is what we call in Python the REPL, R-E-P-L. Incidentally, in realpython.com/bonus, some of the resources there are about this REPL, this interactive environment, which is a very powerful tool to explore things. I'm using it here to show you things, but it's an important tool when learning Python. So feel free to read more about it at /bonus. So far, we've created in my code, I've created a few different types of information. For example, let me create my number. Make it equal to 7 or 6, whatever. Let me create my name. And this is the string. That's why there's the quotation mark, Stephen. I could also create what's called a list of numbers. And to create a list, we use square brackets. We've used all the brackets, right? Parentheses, curly brackets. These are the square brackets. And you can put some numbers in there, right? Whatever you want. Now, these are 3 boxes with labels. My number, my name, my numbers, plural. But these boxes contain different types of information. In fact, there's another built-in tool in Python, type, which tells you what type of information is inside a box, inside a variable. So what does my number hold? Not the value, but what type of information? That's an integer, a whole number. What type of information is in my name? Remember, that's the string Stephen. str is Python's shorthand for string. So this is showing me that Python treats different types of data differently. And this is another really important topic in Python. We're only touching on it briefly here. And what type of data is inside my numbers, plural? And this is a type list. And these data types do different things, right? And they can treat them differently. What about range? What type of data is range 1,21? I can actually do that right straight away. And it's its own data type called range. And range is great, but it actually doesn't create the numbers. It's trying to be really efficient. So it will only give you the numbers when you need them. In this case, I actually want the numbers from 1 to 20. So what I'm going to do is I'm going to ask Python to take this range of numbers, 1 to 21, and change it into a list. And now, remember the list was the square brackets, but now instead of me having to type 1, 2, 3, 4, 5, Python did it for me. And you can see that the 21 is excluded. The last number is 20. And this is what I want. I want a list of numbers so that then I can pick two at random from them. So let me go back there and build this bit by bit. So range 1, 21, I've now enclosed it inside list parentheses. So that line is exactly the same as that. It's going to give me a list of 20 numbers. But remember, we like to store things in our program so that we can find them later on. How do I store things? By using the equals, but I always need to give it a label. For example, numbers. The labels can be anything you want. That's a perfectly fine variable name in Python. You shouldn't use it, right? Because you should have something which is descriptive. But this is to stress that there's nothing special about numbers, right? You can use any word you want as ideally something that describes what the thing is. Good. Now, remember, first number, second number still don't exist. One way of fetching them is by saying first number equals. Now, remember that numbers is this list, similar to this one. I can fetch one of these numbers only. So from the list numbers, notice I'm using the square brackets again, but this time there's no equals. The square brackets are right after the name of the list. And I can simply put a number to indicate which one I want. Now here's another Python quirk. If I want the first number in this list, you might be tempted to put in 1. But Python, like many programming languages, not all, starts counting from 0. So the first item in a list is the one with index 0. Okay, looking at a few people joining there. Hello, by the way, if you've joined in and you want to later watch the beginning of this, this is recorded at realpython.com/bonus. Apart from the resource kit, you will also then get an email with the recording once the session is over. So for those who are on X, on LinkedIn, on various places, if you've joined now, it's recorded. So numbers square bracket 0 will fetch the first item from the list. This is not what we want right yet, but let's do this for now. And second number, I'm going to do the same thing. From the list of numbers, now if 0 is the first one, 1 is the second one. Okay, so this will not work the way we want it to, but let me run the code to see that, to make sure this works. And your numbers are 1 and 2, and they will always be 1 and 2 now. Why? Because my list of numbers is 1, 2, 3, 4, 5, 6. I'm taking the first one and the second one. So in this case, this is not fun, right? Because we're always going to get 1 and 2. But remember the random module we brought in earlier. Earlier, we used it to fetch a random integer. There's something else I can do. So once again, from the random module, the folder on my desk, let me open it. And there we go. If you start typing shuffle, shuffle does what you would expect it to do, right? Now, shuffle is also a function like rendint, like print, and we've seen that all functions have parentheses. Now, what goes inside these parentheses? And in this case, I'm going to put the list numbers. So I'm asking Python, can you shuffle numbers for me? Let's check that this works. Print is useful for these checks as well, right? Let me look at, so on line 6, numbers is 1, 2, 3, 4, 5, 6, 7, whatever. Line 7, hopefully we'll shuffle them up. Let me check that that happened on line 8. And it did. So this confirms that random.shuffle numbers takes the list numbers and shuffles them all up in a random order. This means that now the first two, remember I'm always picking the first one and the second one. Since I'm shuffling them, this is fine. Every time, as long as I shuffle every time, if I take the first two in the shuffled list, I'm picking 2 at random. So now you can see that I've got your numbers are 16 and 7. But if I run it again, your numbers are now 13 and 12 because the shuffling gave us 13 and 12 as the first two. This is one way of shuffling your numbers, and by picking the first two, you're always picking two random numbers. Instead of picking two random numbers from wherever, we shuffle them and take the first two. So far, so good? Good, good, good. Let's. There we go. Sometimes I feel like I need three screens to run these sessions. I've got two screens, right? The one you're seeing and another one. Um, Amina asked me, what does, I think you referred to this one, right? What does this list do? So let me go back to my interactive environment. Range did not give me the numbers. You can see that when I say range 121, it actually gives me the same thing, range 121. What range is doing is it's finding an efficient way of telling me, okay, you want the range of numbers from 1 to 20. But in order to save memory, I'm not going to create all of them until you ask me to. So list is going to take whatever I put inside it and convert it into a Python list. That's something that starts with square brackets. So I could take any information, and if Python can convert it into a list, so a list is a sequence of values in order, as you can see here. So range 121, it's sort of giving Python the information, okay, whenever you need this, I know it's the range of numbers from 1 to 20, but I'm now asking, can you put them in a list so that I can see all the numbers? And that's what list is doing. It's converting one type of data, this range thing, into a different type of data, list. Let me give you another example here. Number equals 5. This is an integer. You might recall that if I ask Python what type of data is number, it's an integer. But the str is Python's way of referring to a string. So if I say, can you convert number, which is the integer 5, to a string, it says yes, it can. But notice that this is now the character 5. You can see the quotation marks, single or double are the same, right? So Python took the integer 5 and converted it into a different type of data, into a string. So that's what we're doing there. We're converting from one type into another. And another question from LinkedIn, why is the 1 included and 21 not? So this is very common in ranges of numbers in Python. It's actually almost always the case. Rendent is an exception. Whenever you have a range of numbers, it's what's called a half open interval. The first one is included, the start is included, but the end is excluded. There are reasons for this, which I'm happy to discuss in the Q&A. They're not really important, right, for understanding Python, but it's not just done on a whim. It makes some applications makes them a bit easier that way. But whenever you have ranges in Python, almost always the start is included, but the end is excluded. This is something worth remembering. Okay, I've covered all the questions for now. I'll come back and have a look in a bit. We are done. I've removed, by the way, I've removed the print numbers there just because I don't want to print it every time. And let me run the code now. Every time I press run, it's going to pick two numbers at random. They will never be the same number now. Why? Because I'm taking numbers 1 to 21, I'm shuffling them, and then I'm taking the first two, so I can't get the same number twice. And it's going to tell me whether you've won or you've lost. Good. I'll have a look at questions. I'll have a sip of water. Now, our task was a reminder. So we have this strange lottery. Whenever someone plays, they get two random numbers from 1 to 20. If one is twice the size of the other, you win. Our aim is to find the odds of this lottery. And the way I'm going to do it is by running this lottery 1,000,000 times and keeping track of how many times we win, how many times we lose. That will give us the odds. And this idea applies for lots of things, right? I mentioned earlier I used to be a scientist, so I used to write lots of code that simulates things in real world. And sometimes you just do something a huge number of times. Computers can do that easily, right? Once you've done it once, you want to get the computer to do stuff over and over and over again. So I'm going to make some changes. Just to keep it simple, I'm going to remove these two lines for now. We don't need them anymore. Those were the first version. By the way, at realpython.com/bonus, another thing you'll find is the final version of the code. Don't look at it now, but at the end of the session, you'll be able to check the final version of the code. So whatever, code with me, but then you can always compare with the main versions. I am going to make a few changes. Rather than printing, yay, you won, or sorry, better luck next time, what I want to do now is keep a tally of how many times we've won. So far, we're only running the lottery once, but we're going to fix that. So I want to somehow keep a tally, 0, 1, 2, 3. Every time we win, we add it by 1. So once again, what do I need to do this? Well, I need to store a number. Let me call it number of wins. You can call it number of wins in full, right? But n wins is a bit shorter. Remember, no spaces. Now, n wins doesn't exist. You can see it's underlined in squiggly red lines, but we've seen how we can create these labels. That's equals. And then I can decide what to put inside this box. In this case, I'm going to put the number 0. Why? Because I want to start at the beginning with 0 wins. And then every time I run the lottery, instead of printing, yay, you won, whatever, I want to say, hey, Python, take n wins, and I want you to change what's inside this box. So when I do n wins equals, it's going to overwrite whatever it's inside it. But I'm going to say, take whatever is currently inside n wins and add 1 to it. So the first time, n wins has 0 inside. The first time we win, so the first time the maximum, the larger number is exactly twice the smaller number, Python's going to run line 13. Remember, it only runs line 13 if that condition is true. If the larger number is twice the smaller number. It's going to then, whenever there's a line like this, Python starts on the right-hand side, right? It's going to say, what's currently inside the box n wins? 0. Add 1 to it. 1. Store it back inside n wins. There can only be one box labeled n wins. So this means that the box labeled n wins now has 1 inside it. If I could keep going, the next time this happens, it will go down to 2, up to 2, 3, 4. And if we don't win, I'm not going to do anything. So I'm going to remove that. I don't need to have an else. The else is only there if I want to do something if this condition is not true. In this case, if this condition is true, I'm going to add 1 to n wins. If it isn't, I'm going to ignore it and move on. Now, I want to run this lottery 1 million times. It's tempting to copy and paste. If I told you want to run it 5 times, you might say, oh, I'm going to copy and paste this code, right? Whatever code I need, we'll figure it out. But if I tell you 1 million times, I think no one here would say, yes, yes, I'd like to copy and paste it 1 million times. We never copy and paste chunks of code in Python. Instead, I'm going to ask Python to repeat stuff for me. This is, again, something that's very common in every program you'll run in the future. You almost always want to have a chunk of code you want to repeat. And there are a few ways we can do this in Python. Today we're going to look at a type of loop called the for loop, and I'll show you why it's called the for loop in a bit. Let me write it down and then I'll explain it. It's going to look a bit weird if you've never seen it before. For, which is why it's called the for loop. Now here you can put whatever you want, right? Just like these names are things you come up with, this is something you can come up with. I'm just going to put something there. For something in, and I'm going to once again use range. Remember, range gives us a range of numbers. But in this case, I'm just going to put 1 million. Colon, and I'll come back to it. Range 1 million is the same as 0, 1 million. So start from 0, go up to, but excluding 1 million. But if we start from 0, we don't need to put the 0. So this makes it a bit simpler. But this is the same as from 0 up to, but excluding 1 million. That's still 1 million, right? Because 0 counts. So if I tell you from 0 to 4, 0, 1, 2, 3, 4, it's still 5 fingers. Now, this line says, hey Python, can you please repeat the following lines 1,000,000 times? And that's where the colon comes in again. We've seen the colon before after if. Let me remind you what the colon does. The colon says, coming next is a chunk of code that belongs together. And in this case, the chunk of code that belongs together, that's what I want you to repeat 1,000,000 times. So which lines do I want to repeat 1,000,000 times? Let me take these two for now, and then we'll see whether we want to add for them. How does Python know they belong together? After a colon, the lines that belong together need to have at least one indent. So I'm going to select both of them and press tab. This means that they both move forward. Do you see them move forward? Shift tab brings them back. Tab moves them forward. Why did I do that? You don't want to do them one line at a time, because this means, notice how line 14 already had a tab, an indent, because it's part of the if. Now it has two. And this is something that, until you get used to Python, can look a bit weird. These gaps in the beginning of the line, these indents, are part of the language. They're really important. They're not there just to make it look tidy. They're not like when you start a new paragraph when you're writing and you put a bit of a space. That's just cosmetic. In Python, these really mean something. So, hey Python, can you please repeat the following lines 1,000,000 times? The lines that I want you to repeat are the ones after the colon, and they're the ones that have at least one indent. So line 13 has an indent, line 14 has at least one indent. Then there's a second one. The second one is because it's part of the if. So that's how Python decides what to do when. Line 17 does not have an indent, so it's not part of the for loop. It will not be repeated 1,000,000 times. Now, we're not there yet. You may already be thinking that there's a flaw here. But let me change the sprint at the end to make something a bit more interesting, right? And I'm going to use once again the F strings, the formatted strings. Remember, we put an F in front of the string. A reminder, realpython.com/bonus. Some of the resources there are a deep dive on F strings and how to use them. I've seen Amin on LinkedIn. I'm not sure whether it's a question or not. That's indenting. Yes, we call that indents. So I'm not sure whether you're confirming that. If it's a question, let me know in the chat and have a look. I would like to print the answer here, right? I would like to say, what should we say here? Probability, I spell it correctly, yeah, of winning is. Now, remember how the F strings work. I can put a curly braces there, which is like a placeholder. Earlier, we've put variable names, these labels we put in, first number, second number. But you can put any valid Python expression inside these curly brackets. So what's the probability of winning here? I'm going to be running this 1,000,000 times. Number of wins is going to tell me how many wins I have. So I can ask Python to do the math for me. Number of wins divided by 1,000,000. I'll change this in a bit, right? But let's see how this works. So probability of winning is, and Python is going to work out the sum of number of wins divided by 1,000,000. This won't work yet, but let's run it and see what happens. So your numbers are 19 and 6. Probability of, actually, this is no longer relevant, right? Your numbers are, we'll change it in a bit. But after running it 1,000,000 times, it said your probability of winning is 0. That's unlikely, right? At some point, we are going to get to win. So what's happening here? While I give you a second to process this in your head and have a look at the code, I'll have a look at LinkedIn. Yes, so your question, Amina, is why is this especially important to indent in Python? So Python is using this indent to determine, for example, here, I'm asking it, can you repeat the following lines 1,000,000 times? But how does Python know which lines to repeat? It's going to look for all the lines that have at least a matching indent, 13 and 14. Then it gets to, remember, blank lines don't mean anything, right? Let me remove them just to make it clear. The blank lines are unimportant. So when there is a colon, such as at the end of for something in range, Python says, okay, which lines belong to the for loop? The first line will always have an indent. Which other lines have the same indent? 13 and 14. 15 doesn't. Therefore, 13 and 14 belong together. That's why the indent is really important in Python. Now, why didn't this work? Because how many times am I shuffling the list at the moment? Once. Remember, the only thing that's being repeated is whatever is inside the for loop, as we say. So only lines 13 and 14 at the moment are being repeated. I'm only shuffling the numbers once, getting first number once, and second number once. Therefore, I always have 16 and 3. I don't want that. I would like to, so I'm going to cut this line and paste it there. Notice I went after the colon just to make it easy. Your editor will automatically put the cursor at the right place after a colon. And then I've pasted random.shuffle. This means that every time, a reminder, lines 12, 13, 14 will keep looping. 12, 13, 14, 12, 13, 14, 12, 13, 14, a million times. Now I am shuffling the numbers every time. But that's not enough because I also then want to reassign first number and second number. So I'm going to cut these lines from there and put them after I shuffle. So I'm shuffling the numbers, and then every time, a reminder, lines 10, 11, 12, 13, 14 will keep repeating over and over again. So every time I repeat, I'm shuffling the numbers, getting the first two in the list, and now this is going to work with different first number and second number. Let's try. By the way, line 5 is, this was showing me numbers, right? I could move this inside the for loop, but then it's going to print this out a million times. I don't want that, so I'm going to remove it. I no longer want to see the numbers. It's working. It's not, it didn't take too long, as you can see, right? A million times. It ran this a million times. And now the probability of winning is 0.052549, etc. We have an answer, right? So this is what we were trying to get. I'm still going to add a bit more, but we have reached our final destination, if you like. We started off saying we have this strange lottery where a player gets two random numbers between 1 and 20. If one of the numbers is exactly twice the other, you win. What are the odds of winning? We have an answer, 0.052549. Now, I'm going to make this a bit nicer. I did mention that we're going to cover lots of topics and I can't cover them all in detail. So here I'm just going to show you a nice trick. But then I'll refer you back to what, let me have a look at, yeah, perfect. Let's just tidy up the chat there. Brilliant. Just, oops. Sorry, I hope, if you've just asked the question, can you ask it again, please? Because my chat has reset there. Apologies for that, but okay. F strings. We can do some really nice stuff with F strings. So we've seen that inside the curly brackets here, I asked Python to work out something for me. Now, I can even format this in fancy ways. For example, and I'm only going to show you these as an example, right? And I'll tell you where you can read more about them. If after this expression, number of wins divided by 1 million, I put a colon and a percentage sign, I'm sending the F strings the information that what I want now, let me run it. The best way is to show you. It took the same number, but now it's showing it to me as a percentage. Rather than me having to work it out, I had 0.05. I would have to multiply by 100 to make it a percentage. The percentage sign there does that for me. Programming is about making your life easier, and Python has lots of tools to make your life easier for you. I can also do something else. I can also put a point 2 and see what this is going to do. The point 2 there says I only want 2 digits after the decimal point. So now it's a bit neater, right? 5.26 rather than 5.2, whatever, whatever. Now, these are what's called format specifiers. If you want to read more about them and f strings, I've mentioned this before, but I'll mention it again for those who are coming in and out, realpython.com/bonus. I've got a resource kit for you, including resources about all of these topics. One of them is f strings, so you can explore f strings and how they work in lots more detail. Good. Let me, perfect. We're almost there. What else shall we do? So we've got that. A few things. Let's assume now I want to run this. There are two more things I want to do, and then we'll go to the Q&A at the end, although we've been answering questions as we've gone along. Let's assume I want to try to get a slightly more accurate number there. And I want to run this instead of 1 million times, 10 million times. Now, I'll need to change this to 10 million, but I would also need to go and change this to 10 million. And I may have other places where I've used this 1 million and changed it to 10 million. Here you might say, well, they're not that far apart, but I might be using this number in the same context instead of from line 7 and on line 5026. So normally we try to avoid hard coding numbers in our code, that if you want to change them, you have to remember where they all are and change them all. What do we do? It's the storing once again. Rather than writing the 1 million there, I can create another storage box, another variable. Let's call this number of repeats. You can call it whatever you want, right? And I'm going to make this equal to 1 million. Now, there's another trick we use in Python. Sometimes you can put underscores. That's still 1 million. That's similar to, you know, when you put commas in between the thousand separators. It makes the number easier to read. That's clearly 1 million. There you have to sort of count the zeros. So that's just a neater way of doing it. So now I have a box labeled number of repeats, which contains 1 million. So on line 8, all I need to do there is number of repeats, the label of the box. Same there. And therefore, from now on, if I want to change how many times I want to run this, for example, I want to do this 10 million times, I don't need to remember every single place I've put the 1 million. I just change it there, and n repeats, wherever I use it, is now going to be 10 million. So I'll run that. I've got a question. Do f strings allow the conversion to percentage form? Yes, so that's what the percentage is doing there. It's taking 0.05, which is 5%, right? So it's showing it as 5%. So once this runs, you'll see that's exactly what it's doing. So it's a convenience, right? Rather than you having to convert it yourself and then put the percentage sign, it's a simple way of making your life easier. I'm not sure I understood your second question there, Amina. Why is it important in Python? I know that this is a good way of structuring and organizing code in, for example, Java. I'm not sure I followed that question, so if you can perhaps rephrase it, I'll come back and have a look at it in a second. So you can see that here, we've now run this 10 million times, and we got our probability of winning, which is 5.27%. I've got one more thing I'm going to add, and I'm going to go through this last thing quite quickly. A reminder, in fact, a quick reminder here that I've mentioned this many times as I was going through. There is a list of resources linked to this workshop, and here you'll find, so this is realpython.com/bonus. Get to it before the end of the session. I'll remind you again at the end. You'll have a list of resources, real Python resources, covering every one of these topics that we have. We talked about f strings, we talked about if statements, we talked about for loops, we talked about the interactive environment. So I've curated a list of resources so that if you want to take the next step on all of them, you have it there. You'll also get the code, the final versions of the code or tidied up versions of the code we're writing so that if something doesn't work in yours, you can compare it to mine. There's also some other goodies. There's a cheat sheet there, which is quite useful. And not there right now, but once you go there, you'll then receive an email with a link to the recording so that if you've come in and out during the session or maybe you've just joined, the recording will be there. Get to realpython.com/bonus and then you receive an email at some point tomorrow with the recording. Good. One last thing I want to add. Keep the questions coming in and then I'll finish off with a Q&A and I'll stay for as long as you have questions. This is not the only way to solve this problem, right? In various aspects of this problem, we could have done things differently. For example, the way we're finding which is the larger number, which is the smaller number. I'm using max and min here, but there are other ways we could do it. In fact, in the code I've given you in /bonus, you'll see different versions so that you can compare this with another one. But let's assume you want to experiment with different ways of doing this. Sometimes in programming, I've talked about functions a lot today. We have print was a function, max was a function, min was a function, shuffle was a function, rendint was a function. Sometimes it would be convenient if we could invent our own functions, invent our own words, create our own functions. I've mentioned that functions are like the verbs of a language, they do something. I'd like to think of them as something else now. It's like a mini program within the big program. So I would like to, for example, I would like to take this logic so that I can maybe replace it and test other ones. Can I, instead of having to write all of that, can I somehow replace this with a new command, a new function that I create, that I invent? And the answer is yes, we can do that. In fact, this is one of the most powerful tools in Python. So although we don't need it in this project, I want to introduce it so that you've seen it. I'm sort of forcing it into this project, but it's a useful thing to know. So it doesn't matter where you do this, right? As long as it's before we're going to use it. So let me go at the top just to make it easier. I want to invent my own Python word. I want to create a new function. In fact, I'm going to define a function. And the word we use for this is def, short for define. And following def is the name of the function you want to define. And just like these names, numbers, number of wins, you can call this whatever you want. That's a very good function. So that's a valid function name. It's not a good one because it should be something descriptive. So for example, in this case, we could say, let's call it check for win. Same rules, you can't have spaces. Otherwise, call it whatever you want. Now, functions need parentheses after them. You remember print had parentheses, max, min, shuffle, etc. But in this case, I want to say, look, here I'm defining this function. It's like a mini program inside my main program. But I'm going to say, when I use this function, I'm going to give you 2 bits of information. You can call them whatever you want, right? First and second. I'm not using first number, second number, just because these could be any number, any names you want, right? So I'm just going to call them first and second here. The colon, we've seen it many times already today. So def is defining a new function. The colon is saying, coming next is a chunk of code that belongs together. In this case, the chunk of code that's coming next is the definition of the function. So what should this function do? Notice the indent, because after the colon, we need a chunk of line that has an indent. And I'm going to repeat something I have there, right? I'm going to write it again from scratch, which is easier. If the maximum of, now, in this case, I'm calling them first and second, because that's the names I gave them, right? First and second. Here I had called them first number, second number. Doesn't matter what you call them. If the maximum of first and second is equal to twice I'm repeating this line, right? So it's very similar to that line. The minimum of first and second, but now I'm going to do something a bit different here. A function does something, and then it returns something back to the program. It gives us something back. For example, max, what does it give me back? It gives me back one of these numbers, whichever one is the maximum. Min gives me the minimum. So some functions don't give us something back. For example, print just displays something on the screen. But in general, functions give us something back. We say they return something. So here I can say, can you return with one n? That's not a special Python word, return with one n. Can you return something for me? And I'm going to ask it to return true. I've mentioned true when I was talking about the if and the equals equals. Remember I said equals equals gives me either true or false. That's the true, it's an uppercase T. I'll tell you why I'm doing this. Else, I'm going to return false. By the way, this function, the way I've written it, I could make it much more compact and efficient. But the aim here is for us to understand what's happening, right? So when you become more proficient, you'll find a way of making this fit into one line. But let's do the long version here. So I'm saying, whenever I use this function, here I'm just defining the function. I'm just teaching Python what it means. And I'm saying, whenever I use this function, I'm going to give you two things, two numbers. If the larger number is twice the smaller number, I want this function to return true to the program. Otherwise, return false. Let me go to line 18, because I'm going to change line 18 now. Why? Because this logic, the maximum, is it equal to twice the minimum? I don't need it anymore now. Why? Because it's inside this function. Instead, remember, if needs to be followed by something that Python understands is either true or false. Therefore, I can use this function I've just created. Check for win. It exists now because I've defined it in line 3. And I said I'm going to give you two numbers. Now, in my for loop, the numbers are called first number and second number. Those are the numbers I want to pass. First number, comma, second number. Now, what does this function do? Whenever I use this function, I'm giving it two numbers. Python goes there and says, if the larger number is twice the smaller number, return true. This means it's going to be if true. That still works for the if statement, right? So if check for win gives me true, the number of wins will increase. If, however, check for win gives me false, line 19 will be ignored. Let me go back to 1 million actually, because 10 million takes just too long to run. 1 million is good enough. And there you go. It still worked just as before. Now, why would you want to do this? In this case, we didn't gain much, right? You could have left it the way it was before, but defining functions allows you to take a chunk of code and make it reusable. If somewhere later on in this program, you again want to run this chunk of code, you don't have to copy and paste these lines or the lines we had before. Now you have a new command. Whenever you want to use it, you can say check for win and put the two numbers. So this is a way of making a chunk of code reusable wherever you want in your code. And that's why functions are really great. You can also, for example, here say, let me define another function. Check for, oops, I don't want to do that. Check for win. Let's call it version 2, right? First, comma, second. And I'm not going to write this code. So here, I'm going to put 3 dots because after the colon, you have to put something. And 3 dots is a valid placeholder in Python, right? So, but here, write whatever code you want. So if you want to experiment and say, I think I have a different way of checking whether the larger number is twice the smaller number, you can do that in this function. And then all you have to do is, instead of using check for win there, you replace it with check for win version 2. So using functions makes it easy to swap them in and out if you want to test them as well. But the main purpose of functions is to make a chunk of code, in this case, the function definition, reusable. Now, whenever you want to do that, you've created a command to do it for you. And that's a good place to stop with our program. So we have worked out the probability of this lottery. So now, if you are running this lottery, you know how many people to expect to win it for you. Good. I'll finish off with a Q&A. We have been answering questions as we went along, but if those of you who are have been following, you still have questions, the Q&A can be about what we've done here. If you want to go off a bit of tangent as well, I'll judge, feel free to ask whatever, or if you have questions about your Python coding journey, wherever I can answer them, I'll answer them as well. So while you think about any questions you might have. A reminder, those of you on Zoom, if you want to, you can type in the chat, of course. I'm having a look at the chat. But if you want to come on stage, as it were, and ask me using your voice, feel free to raise your hand. If you're on X, LinkedIn, YouTube, wherever, you should be able to write the question in the chat and I'll see it. While you do that, let me remind you of where you can get some useful stuff. So I've mentioned this as we went along. I've got a resource kit for you linked to this workshop, realpython.com/bonus. You'll get a number of resources about all the topics we discussed today, variables, f strings, for loops, defining functions, the interactive environment, something else I can't remember. So if you want to dive further with all of those topics, there's plenty of real Python resources there for you that I've collected specific to the topics we discussed today. The code, the tidied up versions, and in fact, different versions of the code we've run today so that you can use it as your reference point. There's a nice cheat sheet about all things useful in early stage Python. And you will also eventually get an email with a link to this recording so that if you jumped in and out, you can watch the whole recording /bonus, and then you'll get an email with the link. Good. Let me go back to my Python editor. I have a comment on Zoom. The docs in Python are docs.python.org. Yes, thank you, Saad, for sharing that. I'll copy and paste your message and I'll share it in the other chat for those who are on YouTube and LinkedIn and wherever. Those are the official Python documentations. Now, a word of warning. The Python official documentations aren't always beginner friendly. I'm not saying don't go there, but they make more sense when you become a bit more proficient. Still use them, but just beware that they're phrased in a way that sometimes you're like, why can't they be phrased in a simpler way? And it's because they're using concepts and terminologies that they're not meant for beginners. But by all means, do use them. If you want beginner-friendly stuff, at Real Python, obviously we have lots of articles and video courses. Some of them are specifically designed for those at the very beginning stage. So as well as the official Python docs, feel free to use the Real Python resources. Derek, yes, Derek, if you can email me. So some of you have attended previous workshops. We had one last week, one the week before. By the way, we have recordings for those as well. So if you go to the YouTube, the Real Python YouTube page, under the live section, you can find recordings for last week's and the weeks before. We've changed how we provide the info, Derek, but if you send me an email, you have my email because you're on Zoom, so you have my email. I'll send you the information. Let me know which workshop you were there last week or the week before, or both of them, and I'll send you the information that was on that page. We're just experimenting slightly with the format, so the page you're referring to there no longer exists, you're right. But send me an email and I'll send you all the info you need. And all, all the goodies you had there, you'll get them as well. Any other questions about today's code? Anything we talked about today that you want me to dive a bit further, or anything about our your Python learning journey? Vinod, captions are off. Is that on YouTube? Yeah, I'm not sure. Is it on YouTube you're referring to, perhaps? I think YouTube can show the captions automatically, but bear in mind all of these tools are using automatic captions. But I'm not sure whether that's your question, Vinod. But I'll keep looking at the chat for another half a minute. But if not, I will bring this workshop to an end. We will have more of these workshops. This was the third in a set of three. We don't have dates published yet for future workshops, but we will have more of these workshops. So keep an eye. If you're on the Real Python mailing list, you'll find out there first. If not, you should join the mailing list, but you'll also find, keep an eye on our social media, and we will have more of these workshops similar to this, different topics. We might repeat some of these topics. So if you see that it's one you've been to already, you don't need to come to it, of course, but we'll have different projects as well. So keep an eye. Saad has a question. Yes, so the recordings of the previous two workshops are, if you go to YouTube and find the Real Python page, I could get the link quickly up for you, actually. Let me let me see whether I can post it quickly. So YouTube, there we go. I think that's there, and I'll paste it as well. So that should take you to the Real Python YouTube page where there are the streams, and you'll find there's we've run two of each, right? So there are two from the 2 weeks ago session. It doesn't matter which one, right? I run the session twice in a day. There's last week's one, and then you have today's one as well. I've run this session a few hours ago and this one. So I've pasted it in all of the chats. Although those of you on X, I think, wouldn't have got the link. But if you go to YouTube, find Real Python, go to live, you'll find the recordings there. Last reminder, well, unless you have questions for me, realpython.com/bonus. If you go there, get the resources, and then you can carry on learning from there. There's a great cheat sheet there as well, the code we've done today, and of course, importantly, you'll get the link to this recording. Good. I will have one last look in case there are more questions. If there aren't, thank you all for coming. If you have joined halfway through, the recording is there for you. And there will be more of these workshops. But in the meantime, you'll find me wherever at Real Python. If you're already in the Real Python ecosystem, come and find me there. Or if not, you'll find me on social media. Wherever you see me, come and say hello, have a ping. I'm very friendly. So, so don't be shy. Wherever you find me, come and say hello. And hopefully I'll see you again for another workshop. As I said, we don't have the dates set yet, but we'll have more of these workshops. So keep an eye on Real Python newsletters and social media, and you'll see them there. Goodbye, and good luck with your Python journey.